Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 90 of physics. In today's lecture, we are going to conclude this exercise on reflection and refraction. So let's get started. We are going to do question number 4. Let us first understand question number 4, part A, section 1. Describe how you would establish by a laboratory experiment the relationship between the angles of incidence and reflection for rays of light incident on a plane mirror. So we did this experiment, but for you and for those people who are new to my channel, this is my request to please subscribe and share it with your friend and support me. Okay, there is a mirror which is I am marking it as M. One side of it is silver. Now there is a ray box from which a very fine beam of light, a ray of light is incident on this mirror, and this dash line is showing normal to that mirror. Now if we increase or decrease the angle of incidence, correspondingly we will see that the angle of reflection is also increase and decrease. So red ray is showing that with a particular angle we incident that light on the mirror, and you can see that it is reflected with the same angle which is known as angle of reflection. Similarly, the white ray is incident and you can see that the reflection is there. Similarly, green light ray is there and you can see that there is a reflection. So generally we can say that direct light on the mirror at different angles. Note down the reflected angles in each case. Angle I is equal to angle R. So angle I is equal to angle R is the relation between the angle of incidence and the angle of reflection. That is what the first part was saying. The second part is saying how does the reflection of a parallel beam of light by a sheet of white paper differ from that by a polished metal surface. Explain your answer. So let us do this. First, I am explaining here reflection from a white paper. The parallel beam of light after striking the white paper will disperse in different direction. The reflection is known as irregular reflection. So the light will spread in different directions, and we understood that from the theoretical portion that if the light of beam parallel coming and striking an unpolished surface or rough surface, then the light reflected after striking that surface will disperse in different direction. So that is called irregular reflection, and if it is from a polished surface, the reflection will be a regular reflection. In that case, angle I will be equal to angle R, and we know that from the theoretical portion. For your convenience, I made the diagram of refraction of light as well. The question is particularly asking about the reflection of light, but for refraction of light, we also made there is a glass slab in which there is a ray box 1. When we are directing a light parallel to the normal of that glass slab, so it will pass that glass slab without any deviation. As you can see, from the ray box to the incident ray is directed with an angle of incident to the normal. So you can see that it is bended towards the normal in case of R. So here you can see that angle of incident is greater and angle of refraction is smaller. So when it is emerging out, then again the emerging angle will be larger than the incident angle. In this particular case, this is the incident and this is the refracted of light. So you have to keep this in mind as well. Although this is not the part of a question, but for your convenience, I did this. Now let us turn our focus to question number 4. They given us a figure which is half of this, not this full figure. I made this figure. The question is saying that you can make the lady body as a straight line and label it as D, which is head, E, which is eye, F, which is feet. So let us understand the question, what the question is saying, because understanding the question is half of the solution. So listen carefully that what the question is saying. In the diagram, DEF represents a person standing in front of and looking into a vertical plane mirror. GH, you can see the labeling. D represent the top of the person head, E the eyes, and F the feet. The height of the person is 150 centimeter. Keep this in mind because we will use this 150 centimeter in the answer. And eyes are 10 centimeter below the head of the top of the head. Number 1 part, they are asking copy the diagram into your answer book. Your diagram need not be drawn to scale, and D, E, F may be represented as a line as I told you. So I copied it because I was having the resources with me. So I revert that image and then made it, although it took quite a long time, but for your convenience, originally I made it like this. So this blue light is the first part is saying show on your diagram the path taken by a ray of light which travels number 1 from the top of the person head and enter the eyes. So this blue line is showing that criteria. First you have to draw equal distance from here to here, a line, and then from the head you have to direct a ray into the eyes of that person. So this is showing that how the person will see his or her head in the plane mirror. The second part is saying that from the first person feet and enters the eyes, in each case mark the angle of incidence and reflection at the mirror surface. So you can see that I made this red light. First you have to draw two lines going from the feet to the mirror and from the mirror to the feet of equal size. Then this well this green light is showing that it is going to this area and then it will be directed to the eyes of the person, and then you have to extend this line like this, and in this way the person will see the feet of the object in the mirror like this. So that was the whole story about the second part of section number 2. Now number third part is saying calculate the minimum length of the mirror if the person is to be able to see a full length image of herself. It means that how much mirror is required to see a person his or her full image. So let us calculate that. I have written at the top that there is a triangle E, C and D, which is this one. There is a triangle E, C and D, and you can see that this AB is intersected at the middle. So from here we can see that AB is equal to half of the CD. You can see that it is the half of the image. Here it is 1/2 and 1/2 portion is this one. So because the image will also be 1/2 and 1/2, half of the image will be above and half of the image. So CD is this one. So I wrote 1/2 of CD means half of the CD, and because CD is the height, so I replace this CD with this H. So what does it mean? It means, so if mirror is half of the height of image, the observer will see her full image. If there is a half of the mirror, you cut this portion of the mirror and only this much mirror is available, still the person will be able to see her full image. So half of that was the question, that how much of the mirror should be there so that the person see her full image, and through calculation we found that half of the mirror is required to see a person her full image. Now the fourth part is saying that suppose that the mirror is moved away. Now let's complete this third part, then we will move towards the fourth part. I have written in this particular case the summary of this. Minimum length of the mirror required for an observer to see her complete image is half of her height. Here h is equal to 150 centimeter. So because this one over 2 of the h will be 150 divided by 2, which is equal to 75 centimeter. So 75 centimeter of the mirror is required to see the full image. Now fourth part is saying, suppose that the mirror is moved away from the person at a speed of 1 meter per second. Determine the speed at which the image will appear to move and states its direction of movement. So let us say that velocity of the mirror, if somebody is moving the mirror, with which speed the image will move, that is the main question. So velocity of mirror is equal to Vm is equal to 1 meter per second, because the question itself is saying the person at a speed of 1 meter per second. The velocity of the image will be minus 1 meter per second. What does it mean? Negative sign shows that the direction of image is opposite to the direction of mirror. So the question is saying that in which direction it will move. Show the direction of the movement. So it will be opposite to the movement of the mirror. Now we have to find the relative speed between mirror and image, and that will be Vm minus Vi, speed of the mirror minus speed of the image. I put the values, and 1 minus minus will become plus, so 1 plus 1 2 meter per second. What does it mean? It means so the image will appear to move at 2 meter per second. And that is the whole story. The final question is question number 5. And question number 5 has given us this figure, which you can see right now on your screen. Now the question is saying, in an experiment to determine the refractive index of glass, a student shone a ray of green light onto a thick rectangular glass block as shown in the figure. They are saying that there is a green filter, which is this one, and that green filter is placed in the path in the light of lamp, and there is a slit in which there is a small aperture here. So from that a very well fine beam of ray of light will pass like this, and there is another block of the rectangular glass block. He marked on a sheet of paper placed underneath. There is a sheet of paper underneath this rectangular glass slab. The direction of the ray, the path of the ray is it entered and left the block. So number 1 part is saying copy the outline of the block and the light ray into your answer book and complete your diagram to show the path of the ray as it passed through and finally left the block. So I shown it here for your convenience that red ray and this blue line is showing normal of the glass slab. So you know that when light ray enter from a rare medium to a denser medium, then it will bend towards the normal. So in this case, this red ray is bent towards the it bended towards the uh, normal, as you can see. And then when it is emerging out in this particular area, it will move away from the normal. So for that particular purpose, I made two normals. One is for entering the incident ray and one is for outgoing incident ray. So you have to copy this on the paper beneath the glass slab in this particular way. That was the first part. The second part is saying on your diagram, label the angles which should be measured in order to determine the refractive index of the glass block. So with white pencil, I mark this angle and this angle for incident light and this angle for emerging of light. So these angles must be precisely noted down, and then after necessary calculation we will be able to find the refractive index of this rectangular glass slab, which is the main purpose of this topic. Number third and the final part of this question is saying how could you improve the accuracy of value of the refractive index obtained by using this apparatus. First of all, to make sure that this angle is equal to this angle, this should be measured precisely, and this angle must be equal to this angle. So in case if these angles are not the same, then you committed a mistake. Take the readings again. First, measure to improve the accuracy. The second one is, and that is very important, and that is parallax error. While taking the radius, you have to keep your eye above the measuring instrument, whether that is plastic or glass ruler or the protector in which you are measuring the angles. You have to put your eyes above the instrument so that parallax error should be avoided. And you know that what is parallax error from the first topic of this course. So that was the whole story about this chapter. In the next lecture, we will start diverging lenses, which is a part of optics. Optics is also a very important field of physics in which we will study converging lenses, as well as a very brief look will be given to diverging lenses as well, in which concave and convex lenses. So leave that for tomorrow. Thank you very much for your time. Have a nice time. Allah Hafiz.